Hello everyone, so it's good to see you all again. I'm NATASHA and welcome back. So today we're going to continue our 5th chapter and it's complex numbers and quadratic equations. So, we're soon going to discuss about the quadratic equations, but before that, let's complete this complex number topic. So we have some few more topics to discuss in complex numbers. So guess what? What's going to be our today's topic? Okay, well, of course, how will you know that? So I'm going to tell you. So of course, it's going to be square root of a complex number. We have studied about the modulus of a complex number, algebra of complex numbers, and we're soon going to discuss about the polar representation of complex numbers, polar form, and a conjugate of complex, so like a lot of things. And in this video, we're going to discuss about the square root of a complex number. That's it, nothing else. So let's get started with our today's new topic. Okay, so what is it? Square root of a complex number. So let's say I have a complex number z, as usual. So what I'm gonna say, yeah. So I'm gonna say the square root of z1. Okay, let's take this z1 as a complex number. So what I'm saying is square root of our complex number, as z1 is a complex number, right? Yeah. So our today's topic is going to be all about the square root, like how to find it, and are there any formulas related to it, and we're maybe going to solve questions too. I'm not sure if we're really going to solve the questions too, but let's see how much time we'll have. Okay, so square root of z1. Okay, so let's say I have a complex number z, which is equal to a plus iota b. Well, of course, it's a rhyme. Okay, so I'm going to say this, that I have a complex number z, which is equal to a plus iota b, right? So if we have to find the square root of this complex number, then I'm going to take it in a little different way, okay? So what do we have to find? That if z is equal to a plus iota b, then the square root of this complex number, or I'm going to say of z. So for this complex number is, okay, yeah, so then the square root of the complex number, what? So I'm talking about this complex number, and now I'm going to say this, let's say, let's assume that z1 is equal to x plus iota y. Oh wait, let me write it again, okay? I think it's a little dark. Oh, no, it's opposite. It's a little light. Yeah, so we're assuming, okay. Well, there's no need to write what I'm saying exactly. So I'm going to just write it in a really short way. So I'm going to say assume z1, square root of z1 is equal to x plus iota y. Okay, so we're assuming that the square root of z1 is equal to x plus iota y. Okay, so one thing that I want to say about this is okay, so one thing I want to discuss with you is about Okay, so what was our last lesson about? It was about modulus of a complex number, right? And we solved some questions. So what I did, I used a formula in that topic too. So there will be a formula in this topic too, but before that we need to understand this concept, okay? So you have to understand it, like what is it and how we're going to do it, and like why is it that important, or how much is it important, you know, while solving any questions or whatever. Okay, so we're assuming this z1 is equal to x plus iota y, right? So, I'm going to first of all square both the sides. I mean the left hand side and the right hand side. So I'm going to, I'm squaring it. So on simplification too. So on simplification, we get, what do we get? So first I square both the sides, right? So what I got from it was okay, let me just show you here. Okay, so what I'm saying is, what's the value of z1? What's the value of z1? What's the value of z1? Okay. Let's just not get confused. Maybe there will be some things. So, what's the value of z1? z1 is equal to a plus iota b, right? A plus iota b. Oh, okay. There's just a small mistake. I forgot to write this 1 here. Okay, now it's z1. So z1 is equal to a plus iota b. So now, what's the value of z1? What is z1? So it is, okay. Finally, this marker isn't working right now. It needs some ink. I'm going to fill it later. Okay, whatever. That doesn't matter. I've changed the marker. Okay, yeah. So what is our z1? It's a plus iota b, and which is equal to x plus iota y, right? Right. So on squaring both the sides. So first I squared both the sides, and on simplification too, I get a plus iota b, no root. Actually, there isn't root. We have done the simplification, so no root here. So a plus iota b is equal to x squared minus y squared plus 2xy iota. Hey, you might be wondering, how did I write all these things? How did I wrote it? You can put it in bracket too. So what was all these things? So what I said, that I squared both the sides, and then I simplified them too. So this is how I got it. Okay, in modulus of a complex number, what do we do if we have to find it? Let's say this is a plus iota b. So this complex number z is equal to a plus iota b. So the modulus of this complex number will be a squared plus b squared, right? This usually happens in modulus of complex number, but it's not in square, in finding the square root of a complex number. It's totally different. It's not related to that thing. Got it? So I don't want to confuse here. And so this is an identity, I can say, a small identity I got right here. So now the final step, what I'm going to do is I'm going to compare the real parts and the imaginary parts. So on comparing the real and imaginary parts, what do we have? We have our a is equal to x squared minus y squared, and b is equal to 2xy. As iota is not going to come here, as we're talking about the imaginary part. I have told you this a lot of times. Okay, so on comparing the both the real and imaginary parts, both sides of what do we have is the real part and imaginary part. All right. So on comparing the real and imaginary parts, I got this a is equal to the value of a. So it is a is equal to x squared minus y squared, and this b is equal to 2xy. So to find the square root of a complex number, first of all, we need to find those complex numbers values, right? Then after that, we'll be able to find the square root of them. Like this a plus iota b is a complex number, right? But what is the value of this a and b? So we need to find it, okay? First, then we'll be able to we'll be able to find the square root. Okay? Yeah, so I hope this is clear. This is absolutely easy. So now let's use another identity, okay? So we're using another identity. Okay, another identity. So we're gonna now use the identity, which is gonna be different from this one. So what I'm gonna say is, I think there's no need to write this. I can just even directly write that identity, like what is it all? Okay, so what I have is x squared minus y squared is equal to x squared plus y squared plus 4. Okay, wait a second. I'm gonna write minus here, okay? Minus. Right? Yeah, so just have a look. X squared minus y squared is equal to x squared plus y squared minus 4xy. 4xy, you can even add iota if you want to. So suppose we have to find the value of this x squared plus y squared. Got it? So first, we'll have to find the value of this x and y, which are given to us right here. Like overall, everywhere, just here too, in here too. So first we find the value of x and y, and after in the last slide we'll find the value of x squared plus y squared. Got it? Okay, so I hope this is clear to you. And so to find its x squared, the value I got was x squared is equal to mod z plus, guess what is it going to be? Is it going to be y or x? Is it going to be y or x? Okay, according to this complex number, it's going to be a. Okay? A, as we're talking about the real part, by 2. And the y square I got was mod z minus a by 2. Okay? Is this completely clear to you? If yes, then I'm going to continue. So on further simplification, we get the value of x and y by taking the square root on both the sides. So finally, what do we get? So finally, this square root a plus iota b, square root of a plus iota b is equal to x plus iota y, and which is going to be plus minus a big bracket under root mod z plus a by 2 plus iota under root mod z minus a by 2 and close. Okay? So you can just take it like this way. Got it? Or maybe how about just clean this off, okay? I think there's no need for that, so no need for this thing. So I'm just gonna clean this, and that's it. So what I've got here is actually a formula, okay? What I've actually got here is a formula, okay? So no need to get confused here. As I think that there is no need to get confused. So we don't know if it's gonna be a, the real part is gonna be a. So I'm gonna just write the real part of z, okay? Okay, it's gonna be whole the same thing, but just one thing that I'm changing here is the real part of z. by 2 plus iota root mod z minus the real part of z by 2, and that's it. So this is our final answer. So actually this is a formula we got, okay? So this is the formula we got here, and so this is going to be the formula for finding the square root of any complex number, okay? So I think like that is enough for today. So but yeah, there's one interesting thing that we'll be discussing in the next video, and it is about that we'll try a question related to this topic, square root of complex number, by doing two different methods, okay? So I'll just solve that question in two different methods. So I'm going to use two different methods. Overall, like they'll be same, but there's a little kind of difference. So like in first method, I'll be not using this formula. In the second method, I'll be using it. So, all these things will be discussed for, I don't know what I'm saying. Okay. Yeah. Sorry for that. Okay. Yeah. So, in the next video, we're going to discuss about this topic, the same topic. So, we're going to solve a question related to square root of complex number, which I've already repeated. Like, I'm saying this twice, right? It's the second time. Okay, that doesn't matter. So, thanks for watching and have a great day.